So today we're going to look at solving systems of equations with three variables. In the last few lessons we have looked at systems, both equations and inequalities with two variables, our x and our y, but now we're going to look at systems that involve three variables, x, y, and z. So we can solve systems of equations with three variables using the same methods as we did with two variables. It's just going to take a little bit more work. So we used graphing, we used elimination, and substitution. And you can use any of those three ways to solve systems of equations that have three variables. Graphing cannot be used to solve most systems of equations that have three or more variables because the graphing can no longer be put on a plane since it's not two-dimensional. So then you'd have to think about how it would look three-dimensional, and so that gets a little bit difficult to look at. So we're not going to focus on graphing at all in this lesson. If we want to use elimination, we could, but we would have to match up the pairs of equations to eliminate a variable, and then do the same with another pair of equations to eliminate the same variable, and then use elimination a third time with just our two remaining equations. So I'm going to show you an example of that, but that is a very long process. We can also use substitution, and we have to solve for one equation for one variable, then substitute it into the other two equations. Then we solve the two new equations by substitution like we did in section 3.2. So each of these methods could be used, but each of them take a little bit more to complete these and solve for each of the three variables. So now I'm going to show you an example of using elimination to solve. If you start with these three equations here, you see that we have x, y, and z. And first you want to pair up the equations to eliminate z. We have to pick a variable to eliminate. We decide to eliminate z because they all have the same coefficient of 2. So you pair up 2 and 3 to eliminate z, which you're left with just then 12x minus 12y is equal to negative 84. Then you pair up equations 1 and 3 to eliminate z, and you're left with negative x minus 4y equals negative 18. So we call this equation now 4 and this one 5. Then in step 2, you want to rewrite our two new equations, 4 and 5, and solve for y and x. So we pair those up, use elimination, and we find that y is equal to 5. Then we take our value for y, plug it back into one of the equations to find our value for x. Then in step 3, we want to substitute the values for x and y into one of your original equations. You can pick 1, 2, or 3, back up to the top here, pick any of these three equations, plug in our x and y, and find our z value, which is negative 7 in this case. You see here that the solution for this system with three variables is going to be written as your value for x, then your value for y, then your value for z. And it's still written as an ordered pair. Now I went quickly through the example because we are not going to be using elimination when we are solving these, but I did want to show you that it is possible to use elimination. It just takes a few extra steps when we have three variables. Now let's look at how we would use substitution. So we start with three equations again, 1, 2, and 3 here, and they each have variables x, y, and z in them. So for step 1, we want to choose one equation and solve for one of the variables. In this case, we're going to choose the third equation and we solve for x, which we have here in red. Then step 2, we want to substitute the equation, or substitute the expression for x, so this negative 2/3 y plus 3z plus 4, into each of the other two equations. So we're going to plug it into equation 1 and equation 2. We do that and we then end up with just two equations, both this equation 4 in blue and equation 5 in blue, and you notice that each one of these only have two variables, y and z, because we eliminated the x using that substitution. Then step 3, you want to write the two new equations, and then write the two new equations as a system and then solve for y and z, just like we would have done with just two variable equations. So we solved for z here, found that was -1, then plugged it back in to find our y, which is -9. And then step 4, we can substitute the values for z and y back into any of the three original equations, 1, 2, or 3, and solve for x. So we choose equation 2, find x is 7. Once again, I want to emphasize that our solution is written as an ordered pair, with our first value being x, second value is y, third value is z. So 7, -9, -1. So once again, we see we can use substitution to solve three variable systems. We are not going to use elimination or substitution. We're actually going to use our graphing calculator. So that's why I briefly went through these examples, but I did want to show you that it is possible to use these methods just like we have before. So let's take a minute and look at how we would use our calculators to solve the systems with three variables. So because of how involved it is to solve equations or systems of equations with three variables or more, we recommend you to use a graphing calculator to solve these systems. We can use either matrices, which you would use on the TI-84 calculators if you have those, or some calculators have a system of equations solver program, which is what our TI Inspire calculators have, the ones that we use in class. So let's look at this example. If we have these three equations, 1, 2, and 3, we want to solve them using our calculators. So I'm going to take a minute and switch over to our calculator screen. Excellent. Oh, give me a minute here. Okay, so now that we're to our calculators, I'm just going to briefly show you the steps. They're in your notes, and then we'll practice some in class when we get there tomorrow. So first, when you're at your home page, you want to go to Calculate, so we're going to choose A. Then you want to hit your menu button. You want to go down to option 3, which is Algebra. Hit Enter. You want to go to Solve System of Linear Equations, and we're going to hit Enter again. Now it gives us the option of putting in a number of equations. Well, in this case, we have 3 equations. And then you also, I think you can just hit Enter here, and it will give you our x, y, and z. These are our variables we're going to use. Now in each of these 3 boxes, we want to put in our different equations. So our first one was 12x plus 7y plus 5z is equal to 16. And our second one is -2x plus y minus 14z is equal to -9. Then our third one is -3x minus 2y plus 9z is equal to -12. So now that I have these 3 in, I want to hit Enter, and right away it's going to give me my solution, where 7 is my x value, -9 is my y value, and -1 is my z value. So we can see by just doing this with our TI Inspire calculators, using this solver program, we can easily get our solution. So let's go back to our notes a minute. So as I said before, we're going to look at more examples tomorrow. Since you guys don't have calculators like these at home, or most of you don't, then we'll practice these tomorrow in class. If you do, feel free to practice a couple examples. What I want to jump to now is show you this next page in your notes, and that is if you have a TI-84, TI-83, or some other type of graphing calculator, you can then use matrices to solve the system with 3 variables. So we will go through more examples like that tomorrow, but if you would like to attempt a couple with your calculators at home, feel free. So now on this last page we are going to look at how using a system of equations with 3 variables can help us solve a real-world example. So here in example 4 we have $10,000 in a savings account, and we want to take most of the money out and invest it in stocks or bonds. We decide to invest 9 times as much as we leave in the account. We also decide to invest 5 times as much in stocks as in bonds. How much will we invest in stocks, how much in bonds, and how much will we leave in the savings? So we see that we have 3 different spots that the money could go. It could go in our stocks, it could go in our bonds, or it could go in our savings. So we want to relate what is happening in this problem. So this first equation is that the total, we have $10,000 total, and that is either in stocks, bonds, or savings. So if we add the money in the stocks and add it to the money in the bonds and add it to the money in the savings, it will total to be $10,000. Then we also know from that second sentence, or I'm sorry, the third sentence here, that we decide to invest 9 times as much as we leave in the account. So the money in the stocks plus the money in the bonds is going to equal 9 times the money that we left in our savings. And then the next sentence says that we decide to invest 5 times as much in stocks as in bonds. So the money in the stocks equals 5 times the money in the bonds. So now that we related each of those sentences, we are going to have to define our variables. So we let K equal the money in the stocks, B equal the money in the bonds, and S equal the money in the savings. So with our 3 different variables, we're going to write our 3 equations. So we have stocks plus bonds plus savings is equal to 10,000. Stocks plus bonds is equal to 9 times our savings, and stocks is equal to 5 times our bonds. So with those 3 equations and 3 variables, we can use our graphing calculators to solve this system. And just as a note, we will want to use X for K, Y for B, and Z for S, just so that our calculators, it will work with the system on our calculators. So tomorrow in class, we are going to finish this example. For right now, I will let you get to the questions that are on your notes and make sure you are ready for that quiz. Good luck.